Operators, types of operators, a brief about operators and types of operators, and then variable and data types. Then I will explain variables and data types in detail. Different types of operators. An operator is a special symbol used to perform a specific function. An operator is a special symbol used to perform a specific function. The data items on which the operator applied are known as operands. Depending upon the number of operands, the operators are classified: unary operator, binary operator, and ternary operator. Unary operator, binary operator, and ternary operator. And about these operators and type of, these are the different types of operators. The classifications of the operators are unary, binary, and ternary. The unary operator takes only one operand to process the data, and the binary operator takes two operands to process the data. Unary example is a plus plus, and the binary example is a plus b. It is a plus b. And the ternary operator, the colon, question mark, and this operator, the ternary operator, is used to check the condition, that is a greater than b. That is like a greater than b. Here the classification of operators: unary operator, binary operator, and ternary operator. Unary operator, binary operator, and ternary operator. And there are different types of operators: arithmetic operators, relational operators, shift operators, shiftwise, left shift, right shift, like that. Shiftwise operators, left shift and right shift. Logical operators and bitwise operators and bitwise operators, conditional operators, assignment operator. Assignment operator. The different types of operators are arithmetic operators, relational operators, shift operators, bitwise operators, logical operators, conditional operators, assignment operators. The arithmetic operators are plus, minus, star, and division. And the relational operators are less than, greater than, like that. And the shift operators are left shift, right shift. And the logical operators are and, or, not. And the bitwise operators are bitwise and bitwise, or x and x. The conditional operators are, that is, colon and question mark. And assignment operator, that is normal assignment equals to operator, and compound assignment, that is plus is equals to minus is equals to multiplication star is equals to, and division slash is equals to. And the different types of operators we'll see in detail, and what is an expression, and how the expressions are evaluated, how the expressions are evaluated, we'll see the coming videos. And the next one is variable. A variable is a name given to a memory location. A variable is a container used to store data. Value of a variable can change during execution of the program. During execution of the program. A variable is a name given to a memory location. A variable is a name given to a memory location. A variable is a container used to store data. A variable is a container used to store data. Value of a variable can change during execution of the program. Value of a variable can change during execution of the program. Name is equals to Ranchu. Age is equals to 21. Percentage is equals to 15.32. Here a variable is a name. It is a name to a memory location. A variable is a name given to a memory location. It is a container used to store data. It is just like a container. It holds some value, and the value of variable can change during execution of the program. The value of a variable can change during execution of the program. The value of a variable can change during the execution of the program. The name itself is saying it's a variable. It is a variable. It means it always changes. The value of a variable can be changed any number of times. Variation, changes, variation and changes. Here name, age, percentage. Name, age and percentage are the variable names. Are the variable names. Name variable is assigned with a string, that is Raju. That is Raju. And a variable age is assigned a value is assigned a value that is 21 with a decimal value. The variable percentage is assigned a value that is 15.32, that is 15.32, that is a float type of data. Raju is a string type of data, string value, and 21 is a decimal, and 15.32 is a fractional float type of a value. Here, by seeing this, we can identify that a variable can hold any type of data value. A variable can hold any type of data value. A variable can hold any type of data value. It's a location we can store. It's a location we can store any type of data. It's a location we can store any type of data. It means that a variable a variable is a play a variable can hold any type of data, any type of data, but before storing a value into it, we have to mention its data type. Its data type means the syntax to declare a variable, or the syntax to create a variable is the syntax to create a variable is data type and variable name. Data type and variable name. Data type and variable name. This is the syntax to create a variable. Here name is a variable, age is a variable, percentage is a variable. Name is a variable, age is a variable, and percentage is a variable. In that one variable is assigned a decimal value, and another variable is assigned with a float value, and another variable is assigned with a string value. A variable, its property is it can store any value, but before creating a variable we have to mention the type of data the type of data that we are going to store in that location. The type of data that we are going to store in that location. The type of data that we are going to store in that location. It is with the help of data types, the compiler stores a value into that location. The syntax to create a variable is the syntax to create a variable is data type and variable name. Data type and variable name. A data type determines the type of data that a variable can hold. The data type determines the type of data that a variable can hold. The data type is the collection of data with values. The data type is the collection of data with values having a fixed meaning and characteristics. The amount of memory space allocated for variables. A data type determines the amount of memory space allocated for variables. A data type specifies the possible values for variables. A data type specifies the possible values for variables. The operations that can be performed on variables. The operations that can be performed on variables. The type of the return value. The type of the return value. That is, this is not here. The operations that can be performed on variables. In a simple words, a data type determines the type of data that a variable can hold. That a variable can hold. Different classifications of data types. There are three different kinds of data types are available in C. There are three different kinds of data types are available in C. Number one, primary data types. Number one, primary data types. Number two, derived data types. Number three, user defined data types. Number one, primary data types. Number two, derived data types. Number three, user defined data types. Different classifications of data types. Primary data types, derived data types, and user defined data types. Primary data types, derived data types, and user defined data types. See here, these are the primary, derived, and user defined data types. And the primary data types are called as basic data types. The primary data types are called as basic data types. The primary data types are called as basic data types. Primary data types: char, int, float, double. Primary data types are char, int, float, double. Char, int, float, double. And the derived data types: array, pointer, function. Array, pointer, function. And the user defined data types: union, structure, and enumeration. Union, structure, and enum, enumerate data. These are the different classifications of data types provided in C language for storing different types of data values. For storing different types of data values. Primary, derived, user defined. Primary, derived, and user defined. Primary is the char, int, float, double. Primary is the char, int, float, double. And the derived is array, pointer, function. The derived is array, pointer, function. And user defined is enum, structure, enum, structure data type, and a union data type. Primary, derived, user defined. Char, int, float to store character type of data, to store character value, single character. An integer, this is the purpose of for storing integer type of values, and this is for float, fractional numbers, and this is for double, large fractional numbers. And the derived data types: array, pointer, function. Array, pointer, function. These are the derived data types. These are extracted from the basic data types. These are extracted from basic data types. And then user defined: enum, struct, and union. Enum, struct, and union. These are the user defined. Basic data types are primary data types. A primary data type is predefined by the C language, is provided in the C language, and is named by a reserved word. A primary data type is primary data types are provided in the language itself, and these names are reserved as keywords. Reserved as keywords. A primary data type is associated with a keyword as its name amount of memory allocated for it, type of values, range of values. A keyword as its name, amount of memory allocated for it, type of values, range of values. Type of values, range of values. The primary data types are used to store char int float. Primary data types are used to store char int float. Used to handle character type of data values. Used to handle integer type of data values. Used to handle floating type of data values. The char is used to handle character type of data values. Int is used to handle integer type of data values. Float is used to handle floating type of data values. Primary data types are used to store char, char, character type of data, integer type of data, floating type of data. Character type of data, integer type of data, floating type of data. See, these are the primary data types. Char, int, float, double. These names, that is char, int, these are called as keywords. These are called as keywords. These are called as keywords. Primary data types are used to store char, int, float. See this one. Basic data types, primary data types. Integer. In that one, signed, unsigned. Int, short int, long int. Int, short int, long. Floating. Float, double, long. Character. Char, signed char, unsigned char. The basic data types are again classified, signed and unsigned, float, double, long, double. Integer, signed, unsigned, floating, float, double, long, double. Character, char, signed char, unsigned char. And the primary data types. Primary data types. See this one. Data type, description, memory allocated, range of values, example. Data type, description, memory allocated, range of values, and example for each and every data type. Here, the char handles a single character value. It handles a single character value. That is the memory allocated to it 1 byte. The memory allocated to it is 1 byte. The range of values we can store into that char is a single character. It's a single character. See here, a single character like B, a single character like A. If you mention a digit in between this single quotes, it treats it as a character. And int data type handles one integer value. Handles one integer value. That is 2 byte. The memory allocated to it is 2 byte. 2 byte, that is the range of values is minus 32,768 to 32,767. Examples: 250, minus 30, 4500. The number in between, it should be in between 32,767 to 32,768. Memory allocated is 2 bytes. The range of values 32,768 to 32,767. Float handles one floating point value, that is 4 bytes. Float handles one floating point value, that is 4 bytes. The range is 2147483648 to 647. And example is the fractional value. Double handles one floating point value, that is 8 byte. That is 8 byte. If you want to store a number which is more than the memory size 4 bytes, then we have to opt 8 bytes. That is double data type. Double data type. So these are the data type and its description and memory allocated and the range of values and examples to each data type. Examples that we can store in each data type. Char, int, float, double. Char, int, float, double. Handles single character, handles one integer value, handles one floating point value, handles one floating value of 8 byte. Of the size is 8 byte. Data type memory range. Short int 1 byte, that is 128 to 127, minus 128 to 127. Int or signed int 2 bytes, 32,768 to 32,767. Long int, unsigned short int. Here see the difference between short int and unsigned short int. The size of the memory for short int is 1 byte and unsigned short int is also 1 byte. But the value which we can store in short int is minus 128 to positive plus 127. Here in unsigned short int we can store a value that is 0 to 255. 0 to 255. It means the first bit in the memory it takes for sign. Unsigned means there is no need of mentioning sign for one bit. And unsigned int takes 0 to 65535. 0 to 65535. And unsigned long int 0 to 4294967295. The value is from 0 to 4294967295. Here these are the different data types and each data type have a different memory and its range of values. Its range of values. Once again, the data types are primary, derived, and user defined. A data type determines the type of a data that can store in a variable. That can store in a variable. Primary data type, derived data type, and user defined data type. primary data type, derived data type, user defined data type. Char, int, float, double are the primary data types. Array, pointer, function are the derived data types. And structure, union and enumeration are the user defined data types. The user defined data types. The primary data types are used to store char, that is a character type of data, and integer type of data, and floating type of data. A character is a single character and integer is a number 20, 30, 40, and float is a fractional number, and a float is a fractional number. This is the complete diagram of basic data types. This is the complete diagram of basic data types. Integer, under that signed, unsigned, floating, in that again 3, integer, in that signed 3, signed 3, int, short int, long int, unsigned, int, short int, long int, floating, float, double, long double, character, char, signed char, unsigned char, char, signed char and unsigned char. Here the range of values that can store a value. Here the range of values, the range of values that can store in a data type. Handles single character value. Each data type handles only a single character. It accepts only a single value. It accepts only a single value. Char 1 byte, int 2 bytes, float 4 bytes, double 8 bytes. Char 1 byte, int 2 bytes, float 4 bytes, double 8 bytes. And the range of values is minus 128 to 127 per char. It accepts only a single character. And int, that is 250 minus 30 4500, means it takes a digit. Float, it stores a fractional value. Double, it takes a double value. Here the memory size and range of each primary data type. Of each primary data type. Short int or signed int, long int, unsigned short int, unsigned int, unsigned long int. Short int or signed int, long int, unsigned short int, unsigned int and unsigned long. The memory size of these are 124, 124. The range of values is here. The difference between short int and long unsigned short int is here it accepts only the value up to 127. Here it accepts the value up to 255. So this is about the class is about different data types. Different data types. that is data types. That is data types.